Our project name is Natural Camouflage. I am Brendan Lord.
Christopher Cisco. Our mentor was Ukar. Thank you, sir, for coming today.
Thank you.
Our idea, as cliche as it sounds, after extensive research over the past couple days, or shall I say week, in actual time frame, the idea has been rather common. However, actual implication of the idea has yet to be done in a professional setting. By that I mean there is no actual changing of dynamic coloring given to a article of clothing or material crafted from some various metal. The idea obviously stemmed from the implication of saying spraying onto something, or you want maybe a whiteboard that is possibly a little more, a whiteboard than this. Simply being able to, say, drag your finger down and it changes a color to black, blue, depending on the pressure given to it, and then over time it deteriorates or through electric charge knocks it back to white. The idea in connection to biology to this was the original stem idea, which was cephalopods, those including octopus, squid, cuttlefish, random. I found that they use a certain sort of cell called a chromatophore, which varies in, I believe, 4 or 5, possibly 6 different pigmentations of color, ranging from red to, oh, hello, difference. Sorry. These vary, obviously, from, say, Roy G. Biv, the red, orange, yellow, blue, green, violet, and they work much like a balloon filled with, say, paint or ink. As the balloon stays in its natural form, the color is a dark pigmentation because all of the ink is condensed. However, when you squeeze that balloon, the surface area expands and the ink is spread out over a large distance, and the light that hits it becomes results in a lighter pigmentation. These are those very scientific names known as the chromatophores in extension. I don't really feel like butchering the names of these, I apologize, but I did feel as though providing these would be efficient in terms of explaining the process of the connection to biology. However, over trying to implement this into an actual idea, we found this very difficult, and we had to move on to a different idea, not too much difference, but a different animal that we could base this off of.
The problem with the last idea was resizing the nanoparticles themselves. It's very difficult to take a nanoparticle, increase the size, and decrease the size as well, and still have it attached to something. So I came up with the idea of how chameleons change color. They have lattice crystal, guanine crystals, and a lattice structure on a scale of 130 nanometers was the diameter.
Right.
And the way they change color is they increase the spacing in between the crystals, refracting different light out of it. So if we could take this and implement it to actually make an artificial version of this and be able to control the lattice spacing, then we could make something that could change color. And we could possibly use that to make or recreate camouflage like a chameleon does.
I may add to this, if it wasn't clear as to how this works, the spacing of the nanoparticles themselves, as the nanoparticles condense or increase the spacing, and it allows light, visible light, whether red, yellow, again, Roy G. Biv, determines which lights allow to pass through the nanoparticles as to which ones would be scattered off of it, which you see.
The design was, we first started off thinking that we could change the pressure of well, after we actually artificially created the lattice structure guanine crystals, that we could change the amount of pressure, because that's exactly how a chameleon does it. They change the different pressure levels in their skin and either increase or decrease the lattice spacings. And so what we wanted to do was possibly use electricity to control the spacing between them rather than just pressure. I couldn't think of a way how to actively, I don't, will really just change the pressure, while it's, maybe if we're wearing it, just change, you know, and have it be contrasted throughout the whole idea.
And a basis for powering this mechanism would be, I'd say, a small watch battery located at the bottom of the suit, or possibly even kinetic energy if I had a better understanding of that form of recharging of a battery source. The implication of this obviously would be military application, hunting wear, the dynamic color change of everyday clothing, or even, hey, I mean, you get in a hit and run accident and you feel like you want to get away from the cops. You change the color of your car, you get a slightly better chance of getting away. Technically, it helped you get away from some sort of felony, but I mean, if it did its job, I'm not one to complain. These similar abstract that kind of came to mind, although not necessarily the pivot points of this design, but a possible idea and implication for further uses would be what is already known as a waterproof nanocoating. You've possibly seen it where you take synthesized nanoparticles and spray them onto an article of clothing or material of your choice, and it all of a sudden becomes very water-proof. And this coating is simply just sprayed on with a spray can or a spray bottle that is very cheap, I found, actually. So this allowed us to pretty much come up with the idea that this is something that we can actually do, or it's a possible idea in theory, at least.
We also thought that if we did create this, then we could use even the nano coating, the waterproof nano coating in combination with our idea. So maybe it could be worn underwater.
And granted that it's an electrical source, even though minor, you do want to keep water and electricity separate from each other due to possible electrocution, although minor, from the wearer itself. Other cautions: due to the increased surface area of nanoparticles, obviously you want to be careful due to their higher reactivity. Other than that, the references that we found were rather various. Tried to keep it short and concise so we didn't bore you today.
Very good. I think we're open for questions now.
Yes.
Any questions?
All right. Any questions?
Yes, Dr. Rukar?
I'm familiar with certain concepts like piezoelectric material, right? You apply a pressure and it creates an electric field in the material.
Yes, sir.
I'm familiar with magnetic restriction. The material changes lattice spacing when you magnetize it. But I haven't heard anything like this before. Right?
If you're talking about the pressure, I assume, of the...
Is there any like scientific term, anything like, you know?
I don't believe there was a scientific term attributed to it itself. It was just recently discovered, I believe last year, as of June 16th, 2014, or 2 years ago. Previously, chameleons were thought to have the same sort of change in color pigmentation as a squid or cephalopod, where the color would change due to contraction, retraction of pigmentations in cells. However, the recent studies as of 2014, they found that changing the pressure in the skin themselves, which is still sort of an enigma itself, it changes the colors based on the spacing of the nanoparticles. And there are a couple photos that weren't added in the slide that shows the actual the nanoparticle size and the distance between. I think we have a couple. These are the closest, as difficult as it is to see, as well as the coloring. These right here actually show the spacing itself. I can't 100% explain how the changes themselves due to just at a loss of idea, because it is a rather new study. So I apologize for that, but that's the best answer I can give.
It's pretty recent too, so
Yeah.
We're probably going to be grasping on that as well, the exact mechanism of how that works. And so that's going to be one of the key things that you have to probably confirm and work with Dr. Lukar and make sure that it's actually a feasible, workable part of the project. So back to, as usual, my question all the time. So which aspect of this can we actually show to our, audience in the poster presentation later on? Are you gonna come up with a model with your, spacing stuff, or are you gonna talk about the details of how you can, because basically right now, just like, Igor and the other groups, you pretty much have the concept of what you really wanna do. It's not a matter of, okay, which part of these am I gonna delve into that is really gonna be a big contribution to the success later, in the final implementation of this. So, which of that do you think?
I believe the model itself wouldn't be too hard to replicate due to, especially theoretically, the way that it works. If it's by pressure or electromagnetic current, it shouldn't be too difficult to come up with a model that could simply be, say on the computer, you drag your mouse over and
Yes.
it would, or say a pressure pen, that would change the color based on where it is.
Right.
So coming up with a model, I believe, would be very easy to do and should be expected in the end.
That's awesome. That will be your hypothesis, that will be your objective primarily, right? At the end. Awesome. Any other questions? None? Everybody's happy with the camouflaging of all the chameleons, like Mystique? I feel like Mystique already? I love that. Okay. Well, thank you so much for that.